Greetings and salutations to my lazy chemists here. Today what we are going to talk about is the energy of electrons, and in particular we're going to talk about how we can manipulate the energy of those electrons. So earlier we talked about how the process that we use to make, or the fact that we use processes of light to essentially do a whole bunch of different things. Alright, what we're going to go over here today is how we do that and why it works chemically. Okay, so today we're all talking about the electrons. Alright, so when we're talking about these electrons, what we're going to do is we're actually going to talk about a couple of different states of them. Alright, so normally when an electron is, kind of doing its thing, it's in what's called the ground state here. Alright, and the ground state is its normal state. Now, if our electron is lucky, what will happen is that it might absorb a photon. And a photon is a single piece of light, okay? And it might be able to absorb that photon and absorb that energy from that photon. And when that happens, it can go into an excited state, okay? And that excited state will push it up to the next level, okay? And that's what's going on when we excite electrons. And there's a couple of things that I want you to know about this in particular, that I need you to know. The first is that it absorbs an electron, and then it has to go up an energy level, okay? And that means that it can only go up a very precise energy level, meaning that it's not going to go all like willy-nilly. So this electron can't go like right here, where the marker is. It can't go there because it needs to go specifically on the next energy level. And you kind of want to think about this as a rungs on the ladder type of scenario. All right. And then the next thing that happens is that you can have that electron will end up cooling down to the ground state. So think, this is an electron that's working hard, it's on the outer level, it's been excited, it's doing its work, and then, man, you know what? It's the end of the day, it wants to be lazy, okay? The electron, it's basic chemistry. Just like all the chemists, it wants to be lazy too. So it wants to fall back down to the lower level, that's where it can be the most lazy, alright? And when it falls down to that lower level, it's going to release a packet of energy, and that packet of energy is going to be a photon. And it could either be the same type of photon, or it could be a different type of photon. Alright? And that's what's going on with electronic spectra. So I want you to imagine that we are sitting here and we're trying to do, let's go ahead and say that we're trying to make a blue light. Okay? Well, we can go ahead and find some element that when its electron goes from an excited state to a ground state, it releases blue light. And that's how we manipulate different elements to make different types of light. Okay? And this is something that you guys are very, very familiar with, especially with your phones and your computer screens. What you guys are seeing is that you are seeing thousands and thousands of tiny little components are in your screens that are getting energized at a very specific way so that the electron goes up in energy level and then comes back down immediately. And when that happens, it releases that light. So this process where energy is going in and then we're releasing light out is something that you're seeing right now on your computer screens. And it happens in your computer screens, it happens on your TV, and it happens every time that you see any different, kinds of colors. It's coming from the light that's on the sun, and it's just going on all over, okay? It's just happening so quick and so fast that you don't even notice it most of the time. Okay. And so we're going to go ahead and talk a little bit in more detail about something. So a photon is kind of like, is essentially the single piece of light. And we're going to zoom out on that. I don't want you to know any of that right there. A photon is going to be a single piece of light, and it can either be absorbed or released by an electron. Okay? And if it's in, and then we're going to talk about ground state. So ground state is going to be the starting point for any electron. And I want you to think about that in terms of, that's where the electron is most lazy, all right? So the ground state is when the electron is like lying on the couch, it's got the TV on, it's, got the phone in one hand chatting away, it's got the other hand in a bag of Cheetos and just kind of like munching on them just slowly, like it's literally trying to throw the Cheetos in its mouth so it doesn't have to move too much. That's what the electron is in the ground state. Okay. And, this right here essentially says the same thing. But we're going to go with the lazy chemist example. Why? Because we're all lazy chemists at heart. Okay. Then a photon will come in, and then it'll go to the excited state. Okay. And that means that it's gone up an additional level. Okay. So I want you to go ahead and think about that. The ground state was, you guys relaxing. Okay. Whereas the excited state, man, that's when your mom or dad comes in and you just realize that you haven't done the dishes in 3 days. Okay? And you know that when they come in and make you do the dishes, that you're going to get up right away and you're going to start doing the dishes. You're not going to kind of halfway, sit up and be like, oh, okay, well, I'll get to it later. You know that's not going to work for mom and dad. You know that you have to go all the way to the dishes. And that's what's going on with the excited state. That's where all of a sudden now the electron's kind of working. It's doing extra work. And it can't go halfway. It has to go to the next highest level. Okay? Then, when it goes from the excited state and goes back down to the ground state, that's when it's going to release the photon. Okay? So it's only when it goes down to the ground state that the electron releases that photon. All right? So, one more time, the process is that an electron comes in when the electron's in the ground state. That energizes it, and then it releases the photon, and it goes back to the ground state. Okay? And this is the photon we're really interested in. All right, this is where we have our most interest. All right, and sometimes that's called emission when it does that. Okay, and here's just here's like the formal, the formal type of looking at it. The electrons, it's in the ground state. Light comes in. That's what this one is. This is light coming in. It gets excited. So it goes to an excited state, and then it relaxes back down, okay? And that's when we get a lower, or it releases that energy there, okay? And the way that we first found this is actually through looking at hydrogen. So remember, we had our specific energy levels here for all of our electrons, right? And this is what this is trying to represent. It's trying to be like, oh, we had the different energy levels, okay? And what we looked at was we looked at hydrogen. And when we looked at hydrogen, we noticed something funny, okay? We noticed that hydrogen would only emit very specific lines of energy, all right? And it would emit lines here, 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 and here. And what we discovered was, hey, this was the electron essentially going up to one of these levels. And then each time that it cooled down from these levels, it released all of the energy back down to us. All right? And so by us measuring this and measuring that out in particular, we were able to discover this form and factor of the emission spectra. And yeah, that's essentially what happens. Now, here comes the cool part. Okay. Yeah, here it is again. And so this is what it would end up looking like. We end up seeing these lines here exactly as is. Okay. Now, here's the cool part. Us being able to look at the light that's received is going to be based off of the element that it provides. So each element has a different emission spectrum. So if we're looking in space and we wanted to look at a planet and see what it was made out of, and it gave us this particular line of energy, and this one, and this one, and this one, we could say for certainty that that planet had hydrogen on it, which is an amazing feat. So that's how we can tell and say, oh, this planet that's 25 light years away, it has hydrogen on that planet. So we're able to tell this because we're able to look at this emission spectrum, all right? Which, let's be honest, this is the key to laziness right here, all right? The other method would have to be to go all the way to the planet to discover it had hydrogen only, and then it would be useless to us, okay? Here, we can be extra lazy and we can scan it just using light alone and seeing what wavelengths of light hit us, and then be like, ah, this one has hydrogen, okay? All right, and here, just a second, let's go back here. This is what's talking with the exoplanets. Now, different elements, like these ones here, hydrogen gives us those specific lines, but helium and oxygen give us more. Now, I want you to note there's more lines for helium and oxygen, and the reason for that is because helium and oxygen both have more electrons. So they have more electrons that can be excited, and therefore they have more lines that they could theoretically have. Okay? And this is what I'm talking about when we use that emission spectrum to go ahead and, double check and see like what the composition of different planets are. Okay? Now, this is also something that ends up being involved in the photoelectric effect. Okay? And what's going on with the photoelectric effect is that you can go ahead and have a beam of light that excites an electron so much that it can escape from a surface. Okay? Now, what's something that, gathers light that wants to have moving electrons? That's electricity. Okay? Solar panels work by taking advantage of the photoelectric effect. And what they do is they heat up using the sun's light to eject the electrons, and the movement of electrons is what causes the electrical current there. Okay? Oh, no, I messed it up. Boop. There we go. All right. Now, another thing that we could do to mess with this is by, let's be perfectly honest. It's by lighting the elements themselves on fire. Okay? Now, fireworks work and they give us different colors based off of what elements are used in there. So for instance, this one right here, I could tell based off of the color that it uses the element strontium. It's got strontium in there, and that's why it's that color. This one right here, the one with white streamers, I could tell that this one is magnesium. All right? And these right here are the burning of different compounds that we can see. And here we have lithium, barium, sodium, copper. That one, I don't know what that one's doing. And this one is potassium. So like all of these things are just different compounds that we could just, essentially burn and then give us nice different colors. Okay, this is our exoplanet one. And then another example is neon lights. So neon lights are actually lights that we fill them with a gas, and we just send electricity through that gas to energize those electrons. And the electrons that are in that gas are going to be energized, and when they cool back down, they release that light source. Okay? And these are actually different gases that are in here. So for instance, this is neon, and this one here is a xenon light. Okay? And these are just different noble gases that we put in there, and then because we can do that, we get different light sources out of it. Okay? That's going to go ahead and close us out for today's lecture on, the electromagnetic spectrum. But I was hoping that you guys will see that this is essentially a whole process that we could use to help humans essentially be super extra lazy. Okay. And I don't know of anything that's extra lazy than, literally putting out a solar panel so that can grab our energy for us, or by using the electromagnetic emissions to test a planet from light years away to see what it's made out of. All right. That'll close us out for today. And just like the scientists that ended up finding the lazy way to discover the composition of exoplanets, I need you guys to be lazy.